Here we go. So simplifying radicals. Simplifying radicals. All right. So let me get rolling here, and we'll get rolling, and let me get rid of this, and we will roll. All right. So here we've got a radical, and we talked about some of this yesterday already. So the product property shows that factors. I've already talked about this yesterday, but now we're going to do it fully. At least I think I talked to you guys about this yesterday. You know what? It may be pre-algebra, because guess what? We're doing radicals in pre-algebra right now. And I got to keep straight which class I'm talking to. All right, anyhow, the product property shows that factors of the radicand can be separated into distinct radicals. All right, so technically, here's the idea. You can take this radical and you can split it up. And you can have the nth root, and the n just represents some number, right? If it's a 2, there wouldn't be anything in the index. They'd both be square roots. If it was a cube root, the index would be 3, and both would be 3. If it was a fifth root, the index would be 5, and both would be 5. And you can split up the product. We have an a times b, so you can split, so you can split this thing up. I love it. It's stuck in a weird mode. I'll just leave it. As an a times the nth root of b. Now this is technically what's going to go on. I'm going to show you some shortcuts in a little bit. But this procedure can allow us to take some of the root of the radicand when you can't take an even root of the whole radicand. That doesn't mean a whole lot to you right now, so let me show you a couple examples and see if we can make sense of it. Here's the first example here, square root of 4x. We have a variable, and there's no even way to take the square root of 4x. Yet we can make this more simple. So if we take the principle above, what if I split this up into the square root of 4 times the square root of x? Really, what we're doing is unmultiplying, which is what factoring is, right? Unmultiplying. Now we can do something with the square root of 4, right? Because we all know the square root of 4 is 2. And so now we end up with 2 times the square root of x. And that's a simplified form of the square root of 4x. It's a more simplified answer. This is all a means to an end. A lot of stuff that we do in math is a means to an end. We learn principles, and later on, usually it's equations. We get to the point where we're dealing with equations, and we put all the principles together. It's what we're doing right now. You know, last night when you were converting from radical form to exponent form, you're just trying to learn some relationships between radicals. When you're going from exponent form to radical form, you're trying to learn relationships between exponents and radicals. This is all a means to an end to get you to hopefully understand what radicals are and how they fit together. So right now we're trying to simplify radicals, make them more simple. We're really trying to take the root of anything we possibly can, but here's the point. Keep it the exact value. That's what we're after. We want to keep it the exact value. Now when you have a variable involved, you know, we've got those variables and we've got to deal with that. But that's the point, we want to keep it exact. So if you look at B, again, I can split this thing up into the cube root of 27 times the cube root of n squared. I like that. Because what's the cube root of 27? 3. So the cube root of 27 is a 3. And then that'll be times the cube root of n squared. We can't take the cube root of n squared. There's only 2 n's. Which, I'll try this. I don't know if this will make sense to anybody. But why is the cube root of 27 3? Because guess what? 27 is a 3 times 3 times 3. That's a 27. And a cube root says, what number times itself 3 times is a 3 times 3 times 3? Well, the number 3 times itself 3 times is a 3 times 3 times 3. Whenever you have as many of them as the index, the root is the number. What number is times itself 3 times? A 3. So what's the cube root of 3 times 3 times 3? 3. All right. I'll keep trying. Maybe it'll sink in one of these days. All right, but that's the simplified form. That's an exact answer. Now on C, we have just a number. Go ahead and take your calculators, punch in the square root of 45. So take your calculator, punch in square root of 45. It's going to be 6 point something. All right, so I want everybody to say your answer on the count of 3 as far as your screen will go, nice and loud. Here we go. 1, 2, 3.
6.70820393.
Does the number end right there?
Yes.
No. It goes on forever and ever. Amen. Okay? And we don't want a decimal round off. I don't want a decimal round off. You know, if you're really computing in real life with math, if you round things off and you got to use that number later, what's happening to your final answer? It's getting farther and farther away from the actual value. We don't want round offs. We want an exact answer. I don't like that answer, but I can simplify the square root of 45. So, in my mind, I think, well, a 45 is a 9 times 5. So I can split this up into the square root of 9 times the square root of 5. What number times itself twice is 3 times 3? 3. We all know the square root of 9 is 3, and we end up with 3 times the square root of 5. Go ahead and punch that out in your calculator. 3 times the square root of 5. It's that same number, right? 6 point, whatever it was you said, Of course it is, right? But this is the exact value, 3 times the square root of 5. That's as far as we can go. Can't do anything with the 5. We got to leave it as square root of 5. Because to take a square root, you need 2 of any term. We don't have 2 5s, we only have 1. This is the main concept. Normally, though, we won't go through the step of splitting it up. All right? So let me show you as we continue on and try to show you some aspects. All right, number 2. Come on, Windows. Stop it. Number 2, whenever the number of factors equals the index, the root is that factor. Whenever the number of factors equals the index, the root is that factor. All right. So in A, the index is not shown, but we all know it's a 2, right? What is the square root of n times n? N. What thing times itself 2 times is an n times an n? An n times itself 2 times is an n times an n. That's what square root means. What is the thing that when you multiply it times itself, you get the radicand? What is the thing that when you multiply it times itself twice, you get n times n? Oh, well, an n. And the point is, there are 2 n's, 2 factors. They match the index 2, and the root is the base, the factor, the n. So in B, what number times itself 3 times? That's what the index says, right? 3 index. The green 3 says, what number times itself 3 times is a 7 times 7 times 7? A 7 times itself 3 times is a 7 times 7 times 7. Point. If I have 3 7s and I'm doing a cube root, the cube root of 3 7s is 7. The cube root of 3 11s is 11. The cube root of 3 x's, x times x, not 3x, x times x is x. The cube root of 2.7 times 2.7 times 2.7 is 2.7. The cube root, how about this one? Think mentally. What's the cube root of y squared times y squared times y squared? Do you hesitate? How can you, if you're hesitating on that, then you're really not understanding what's going on. And that's not good. You're going to need to ask questions. And if you ask questions, I will begin to get to understand why you don't understand. But if you sit there like a bump on the log and you don't ask questions, you have to make me try to guess what you're thinking to try to figure out why you don't understand. So let me try again. A cube root means what thing times itself 3 times equals the radicand. So a 7 times a 7 times a 7, because there's a 7 times 7 times 7, there's 3 7s, the cube root is 7. A 7 times itself 3 times is a 7 times 7 times 7. So then what if I had this? What if I had n to the 5th times n to the 5th times n to the 5th? What's the cube root? Now raise your hand if you didn't say anything. Please do it now. Raise your hand if you didn't say anything. High, please. Okay. Now, leave your hand, put them high. I didn't say put them down yet. Put them high. I'm not gonna quit. Put them high, and I'm not gonna stop until you do what I'm asking you to do. High. High. Put them high. Now I want you to leave your hand up if the reason you didn't say anything is because you just didn't say anything, but you actually knew what was going on. If that was the case, leave it up. Okay, so a few of you knew what the answer was, you just didn't feel like saying anything. All right, you can put them down, shame on you. Now the rest of you, you don't know what's going on, you need to ask questions. So again, I can't help you if you just sit there like a bump on the log and you don't ask what's going on. Okay? And if you don't ask, you're going to be lost the whole way through. So, let me see if I can approach it maybe a different way. But again, you're all leaving me guessing why your brain isn't getting this. So you're not helping me, you're not helping yourself, you're just leaving me trying to guess. If I had the cube root of 8, all right, so class, what's the answer to cube root of 8? Why? Right? Do you all know the cube root of 8? How many you don't know the cube root of 8 is 2? Let me see your hand. You don't know that. Okay? So, again, let me ask you one more time, and I heard the answer a minute ago, but why is the answer 2? Just say it out loud. Why is the answer 2? Just talk. Okay, now who didn't talk just then? Raise your hand, please. Whoever didn't talk just then, raise your hand, please. You tell me you all talked. Am I like blind? Do you like talk? Who is a ventriloquist? Let me see your hand. You're a ventriloquist. How many don't know what a ventriloquist is? Let me see your hands. All right, that's the guy that talks through a dummy, where his mouth never moves and he makes the dummy talk. All right? He talks, but his mouth never moves. All right, you understand? A ventriloquist has to talk without his lips moving. You get it? That's a ventriloquist. See, I'm not good. My lips were moving a little bit, weren't they? All right. So some of you are great. You're a ventriloquist. You talk without your lips moving. Say, Mr. Scarfy, why are you being so hard on us today? I'm being hard on you guys because, 1, you're not answering my questions. Number 2, you're not doing what I'm asking you to do. And that's half the problem. And number 3, you're in the dark and you're just staying in the dark. You know why? Because you're afraid to ask questions. And if you're afraid to ask questions, I can't help you. You leave me trying to figure out what in the world is going on in your brain. And I have to be a psychic to be able to do that. Okay, so again, I'll have to trust because nobody's talking, nobody's saying a word. You're all saying you understand this stuff and you don't. Half of you are in the dark and that's a problem. And 8 is a 2 times 4. And a 4 is a 2 times 2. I have 1 2, 2 2s, 3 2s. I have as many 2s as the index. Therefore, the cube root is the number 2. Why? Because a 2 times 2 times 2 is the 8, the index. So that's why we said a moment ago, what's the cube root of 5 times 5 times 5? See, if you're even thinking, you're missing the point. If you're even thinking, you're missing the point. I'm talking about a cube root. If I have a 5 times a 5 times a 5, what's the cube root? It's that number. It's the 5. 5, 5, 5. It's a 5. What's the cube root of a 7 times 7 times 7? It's a 7. There's 3 of them. It's a 7. What's the cube root of n times n times n? And there's 3 of them. The cube root is it. The n. N. What's the cube root of 89 times 89 times 89? 89. All right. What's the cube root of z to the 8th times z to the 8th times z to the 8th? Z to the 8th. There's 3 of them. And whenever there's 3 of them, the cube root is it. Whenever there's 2 of them, the square root is it. All right? What's the square root of t to the 10th times t to the 10th? T to the 10th. There's 2 of them. The square root is it. Okay. Look, this, again, I'm taking a long time, and I got a lot of other stuff to teach, but you got to get this concept down. And this isn't hard. If it's a square root, you need 2 of them, and the square root is it. If it's a cube root, you need 3 of them, and the cube root is it. Here we go, tough one, 4th root. 4th root, are you ready? I want you to tell me the 4th root of a 6 times 6 times 6 times 6. It's a 6. All right, tough one. 4th root of a 2n times 2n times 2n times 2n. 2n, there were 4 2n's. Right? Look, that's all roots are. Don't make these hard. Don't make them hard. Don't make them hard. Don't make them hard. It's easy. Whenever you have as many factors as equals the index, the root is that number, because that's what number times itself that many times has the index. All right, I got to quit at that point. I'm hoping that's sinking in. It may not, and if it's not, oh well. So look, what's the 4th root of, and by the way, if you don't know, a 5 to the 4th means 5 times 5 times 5 times 5, right? Isn't that a 5 to the 4th? 5 times 5 times 5 times 5. So the 4th root is 5. And the 4th root of y times y times y times y is, because we got to figure these out, that's why. All right, so 5y. All right. Long time there. I hope that helped. I hope finally it's making sense, because to me it's too simplistic. And now we're going to try to confuse you, because now we have too many things. Look at A. There's too many x's. How many x's are there?
3.
How many do we want?
2.
Oh. All right, so watch. Here's the long way. What if I made it the square root of x squared times the square root of x? Is that true? Isn't that what we've done earlier in the lesson? Split it up? Okay. Because isn't an x squared times x, x cubed? Okay. What's the square root of x squared? And then it would be times the square root of x, right? We end up with an x times the square root of x. We took the square root of the 2 of them. Now that's the split up way. Most people that understand what's going on, without splitting them up, they'll just do it this way. They'll factor it. And look, because it can split up, I can just do it right now. I can take the square root of that x squared. And I'm just going to cross it off because it's an x, right? What's the square root of x times x? X, right? And what's still left in? That other square root of x. Either way, you get x times the square root of x. Okay, so B. How many of something am I looking for B? How many am I looking for? See, that's got to be your first thought. The index controls everything, right? Because it tells you what kind of root you're taking. So the index says, hey, we're taking a cube root. I need 3 of something to be able to take the cube root of it. How many n's do I have? Am I ready to roll? What's the cube root of n cubed? That part's done. Take your n out. That's done. We took the cube root of the n cubed. It was nice. It had as many as I needed. I needed 3 n's. What's the cube root of n times n times n? It's n. What are we going to do with the 40? Well, we're going to factor it. For the sake of some of you, let me go this route. Let me go 4 times 10. There's a lot of different ways you can factor it. 4 times 10. Let's change the 4 into a 2 times 2. And let's change the 10 into a 2 times 5. Is everybody okay with that factorization? So let you catch up. The 4 is a 2 times 2, and the 10 is a 2 times 5. We all caught up? All right, take your red. Circle the 3 2's. All right, here we go. What is the cube root of 2 times 2 times 2?
2.
We can take the cube root of it, right? Cross it out and put it out front, right? What's left underneath the radical? What is still inside? So that's got to stay inside, right? So this is times the cube root of 5. And we just simplified it. So technically, you would split it up. You don't need to. You can just do it all off the same radicand, understanding it's the same thing. Split it up. Take the root of what you can, factors that you can. I need 3 2's. I got 3 2's. Now look, in this same problem, what if Pamela said a 40 is an 8 times 5, and Pamela says, I know the cube root of 8, it's a, and she took the cube root of 8. Would that be okay with you? It's the same thing. She already knows that an 8 is a 2 times 2 times 2. Which is why the cube root of 8 is 2, right? Same concept. All right, let's keep going here. So with numbers, some numbers you already know their root. So you got a 56. What's a 56? 7 times 8, 56. Remember, how many things am I looking for? 2. I'm looking for something times itself twice. Turn the 8 into a 2 times 4. Now, some people would stop and say, well, wait a minute, I know the square root of 4 is a, and they just take the square root of 4. Other people are not quite understanding everything yet. It's foggy to them, and they'll further factor the 4 into a 2 times 2. Okay, either way, it doesn't matter. I'm going to take my red. Would you agree I can now grab 2 of these 2's and take the square root of them? It doesn't matter which 2 you circle up and round up. The square root of a 2 times 2 is 2. All right, cross that out, get a 2 out front. Can we do anything with the 7 and the other 2? Nope. We're going to leave it. Here, let's use our green. Oh, no, I have an a cubed. Let's factor the a cubed. Now, again, people that understand what's going on, they would make it an a times an a squared. And right off the a squared, what's the square root of a squared? They would right then say, oh, that's an a for that part. Students that are still a little foggy might take the a squared and go all the way to an a times a. But again, what's our index? 2. How many things are we looking for? 2. So circle up 2 of them and take the square root of it. What's the square root of an a times a? A. Can I do anything with that last a in there? No. And what would you do your b to the 4ths? Let's use black on that. How about making that a b squared times a b squared? Now again, people that see it more clearly, they'll take the square root of b squared is Square root of the other b squared is? All right. If you don't see it so clear, maybe you're going to go all the way to b's, and we will pick up here tomorrow.